my research interest mainly in cyber physical systems, particularly on energy systems. So there are a number of cyber physical systems you can work around. My group specifically look at these energy systems, and we do research around cyber security aspects, understanding cyber attacks, its impact, and so on. Now, before I get into the lectures, and possibly we will try to make these lectures more interactive so that rather than me just talking about things, we can kind of understand things. So I have a couple of questions here, which I would like all of you to kind of answer. This will help me to understand what should have contained and what the label of the talk I should be having. So if you can go to a site called menti.com, you can use it your laptop, mobile, whatever, as long as you have internet. If you go to a site called menti.com, it will ask you some code, user code. If you just put this code, which says 13292136 on the top, see, you should be able to answer these questions. There are only 3 questions just to understand what kind of audience I have, and it will help me to shape my talk. So very first question is, what is your current enrollment? Are you BTech students, master students, PhD students, postdocs, or any other? Right, so it seems to be we have a mix of people. So I will talk about some of the solutions, but I will also focus on problems, understanding what kind of challenges are there, and how to apply solution, and what kind of solution will be ideal in certain situations. Yeah, possibly the standard solution you can kind of Google and learn about that as well. So I'll talk about more customized solutions. The second questions I have is, do you have a background in security, or have you studied any security module? Not particularly with cyber security, any security module, information security, data security, network security, cryptography, if you've gone through. Okay, this is very surprising to see no. Okay. And the last questions I have is, so how do you rate your knowledge about cyber physical system security? And why are you interested in it? Have you okay. Right. Well, thank you everyone for these questions. I'll jump to the okay, so I'll jump to the first lecture now. In this particular lecture, I will be talking about holistic view rather than going deep into one particular scenario. We will try to understand how security has been evolved. What is cyber physical system? How it's different from cyber security in a general way. And how these physical systems are different from IT systems that we mostly know. Now, the very first thing we try to understand something what is called critical national infrastructure. We call it CNI in the UK. I think in India we call it National Critical Infrastructure, which is kind of similar thing. So I'm just giving the context of the UK government. So UK government has identified 13 sectors as critical national infrastructure, and kind of the criteria of understanding those terms is any facility, systems, sites, information, people, network, and process necessary for a country to function. So some of these sectors are sectors where we rely every day. Some of these sectors are those sectors which are not part of our routine or daily life, but they are critical for us. And some of those sectors we don't really use, but they are there for protection. Yeah, for example, nuclear sector, we don't really use it, but then it's there. Defense sector, it's there for us to protect us. These 13 sectors, you see chemicals, civil, nuclear, communications, defense, emergency services, energy, finance, food, government, health, space, transport, and water. And you see energy is one of the CNIs. Emergency services, they subcategorize, for example, police, ambulance, fire services, coast guards, and so on. Why we are talking about now critical national infrastructure, and what is the need of it? What is the sudden need? Why there's a noise saying we need to protect CNI? Any thoughts? Yes, yes, yes. It's a backbone of the country, but these systems are there since very long. They're not new systems. Yeah. When you say power grid has been there very long. Water treatment systems, all these systems are not new. But what is new is we are making our world, our system more smarter. Yeah, we want to build a smart city. And what is the definition of smart cities? That we want to place devices that can automate things for us. They can make intelligent decisions. When you walk in, door should be open, light should be switched on, and blah, blah. Yeah? At the same time, they should work efficiently. At the same time, they should be optimized. Once you walked out, everything's shut down, and so on. So this is one of the very simple examples how the smart systems work. Now, in order to facilitate that, obviously, you will put some devices which are talking to each other, collecting some data, sending that data somewhere else to process it, so that certain decisions could be made. And now we are not talking about infrastructure of an organization. We are talking about scalable infrastructure, country-wide infrastructure. Yeah, power system is country-wide. You got electricity from power grids. What if your grid is down? We don't have electricity. So maybe last 10 years back, not having electricity is not a big deal for a few days, even, or for a week. You manage things. We had a system in place. But now we have more reliability on smart systems. We have mobile phones, we have electric vehicles. Yeah, there's a lot more dependency on those systems. Now we can't really live our life without these systems, right? You always look for charger, my battery is draining, whether it's a laptop, mobile, whatever. And let's say there's an attack that can down the grid and you don't have electricity for a month. How will you, especially in winters, where you need hot water, for example. Yeah. In India, it's still manageable, but you can think of countries where the temperatures are really in -10, -20, and you don't have electricity. Because those countries have heating, all over the places, like we have air conditioning. So if you're sitting in -20 without heating, without hot water, you can't survive for a month. Yeah? So that would be a really disaster for that country if something like this happens. It's not just about the reputation, it's about you have to suffer with that harm. Therefore, it's really, really important to understand what is your infrastructure, because it's very different from country to country. Some country might have one grid, some country might have multiple grids. Some countries have really large populations, really high demand, some countries have low demand, and so on. So these, you have to understand system, you have to understand what kind of risk there. So calculating risk is also different from country to country. And then what kind of solution you should come up with that should help you in that context. And that's where we really need to understand what are the sectors, what are their challenges, why it's difficult to protect them. Yeah? As we are evolving with technology, so there's a saying by someone says, technology does not solve your life, it doesn't improve your life, rather it brings a lot of issues. We think this will help us, but it doesn't really help us. Yeah? Because technology can ease things, maybe one or two, but then it might bring several other things that we don't know until system has been exploited by someone else and so on. So we really need to understand technology, really need to understand these systems. What are the issues, challenges that we have as of now and we will have in the next 10 years. So when you talk about a solution, you don't develop a solution just to fix what are the issues as of now. You think like down the line, let's say next 10 years, whether the solution that I'm developing, will it work next 10 years? What will be the challenges in next 10 years? What will be the data look like? Yeah? What is the size of population look like? What is the size of infrastructure look like? What kind of new devices can come into there? What kind of technology can come in? For example, AI driven or whatever. So you need to take into consideration all those things and you develop solution for future. Not for current, not for past. You can't build solution just to think about what happened in the past. Obviously you need to fix that, but you need to think what kind of problem that you will face in next 10 years. And you need to keep in mind when you are developing those solutions. Yeah? So these solutions should be sustainable and scalable at the same time. So if we talk about the threats to CNI, basically I can categorize into four broad categories. One is cyber threat, because we think now we have kind of deployed a lot more smart devices which are connected to internet, exchanging data, and so on. Yeah? So definitely we need to think about what kind of devices are there, what data they are collecting, and so on. Second is personnel, threats from the humans. And one of the key examples is insider threat. So in the US, there have been certain attacks, and we will talk about some of those as a part of tutorials. Some of the attacks were there where attacker cut down cables. Cables in internet cables, telephone lines, underground cables. That's it. An external person doesn't know all those things. They don't know where the cables are, what type of cables those, what connections are there. So definitely there's someone who have that understanding, that have some knowledge. Yeah? Maybe not directly the person who did this, but someone collected that information from the person who was ex-employee of that organization. And then the attacker used that knowledge to target XYZ. When they perform attack, they make sure communication is not there. It's cut down, so you can't report it, what's going on. You can't simply call police or people or talk to other control center or security officer or whatever. You won't be able to do anything when the system is under attack. That we see in the past. Physical attacks are not new. So you go temper a device, you see it sort of power tower, you unplug certain things. It's as easy as that. Yeah? You go to a remote area, you see big towers, you harm those towers. So again, those are kind of very different, but then more understanding about physical attack is how can you perform a physical attack that can destabilize the grid, interrupt your services, and so on. So attackers are not just thinking nowadays just to steal your data. And, that's a very small thing. They are more interested in how to perform an attack that can massively impact the system, Can I disrupt that service? Can I target this particular substation so so it could down the grid for a month, and so on. So they are targeting a large scale attacks. And obviously there are environmental effects. If there's a flood, there's an earthquake, and so on, that possibly we can't control. So in this, we will be more focusing on cyber security and cyber attacks. If we look at this global critical infrastructure protection market, you see it's been growing 3.7%. It's been projected, kind of predicted 2023, but we see this kind of significantly, the growth is significantly larger than what's been reflected here. But we are expecting it will grow at least every 10 years, it will double the market and so on. So there's a lot of players in this, a lot of companies there who wants to contribute to the protection of CNI. Just to give you some context, I was looking into what is what kind of centers we have in India. So I don't know if you know, there's something called National Critical Information Infrastructure Protection Center. So they call it NCIIPC a couple of years back, and now they rename it. It's called, so they have called India.gov.in. Where they, in Indian context, they have identified certain areas where they want to keep an eye what's going on in these sectors, what kind of challenges, requirements we have in the country. And from time to time, they develop documentations, guidelines, and so on and so forth. There's another center we have, Indian Cybercrime Coordination Center, I4C. This is particularly focusing on cybersecurity, where they have mechanism where you can report a crime through their portal. They have a threat analyst unit. There's a team who can manage cyber threats. They got forensic laboratories so that they can also do forensic analysis when the attack is happening, or post-attack analysis. It's a training center, research and innovation center, and so on. Then they have something called Indian Computer Emergency Response Team, CERT. Now, generally, CERT is a country-wide mission which will help you to create teams of different expertise. That's what we call it, emergency response team. Yeah? When something goes wrong, they have a plan in place, and they kind of try execute it. So here you can see they are kind of monitoring what sort of vulnerabilities coming up, CVEs. What is CVE? So it's called Common Vulnerability and Exposure. Whenever they are looking at software, there's a bug, there's a security loophole, we call it CVE. Yeah? So it's been recorded part of CVE and gives a number, and that describes if you are working on Windows Server XYZ, there's a possibility you can inject a malware in this way, for example. So they're monitoring all the CVEs that been discovered from time to time. They're also releasing certain kind of guidelines for citizens, for companies, and so on. They have something called Cyber Swachhata Kendra, where companies, international partners can also collaborate in the mission. So they can kind of strengthen country-wide mission. And they are more particularly focused on phishing activities, because there's a lot of fraud going around with the phishing email or messages. And they got another portal called National Cybercrime Reporting Portal, where you can report again 1930. That's what we hear when you call someone. Yeah, that's advertisement. They created citizen manual, cyber safety tips, cyber awareness, and they release certain digests for people to be more aware. I'm not sure if you have looked at all those documents. So it's good to have this understanding, and possibly we need to build our habit to just explore what's going on there. So you're more up to date, what are the recent threats, what are the recent frauds, and so on. And that's where, based on the kind of incident they report, they release those documents, they prepare what kind of recommendation I need to come up with in order to help citizens with some kind of solution. So they release those reports will help us to understand. Again, these are not technical, I guess, more kind of citizens. Now, what we have in the UK is called NCSC, which is a National Cybersecurity Center set up by federal government. They have an office in London, where obviously they do all kind of things that I'm talking about here, but they are more particularly on mission in a way. They don't just teach cybersecurity on higher educational level, but they want to introduce, and they have introduced cybersecurity at school level, colleges level, and so on. So we have a program called Cyber First. So Cyber First is a program for school girls between 10 to 16, some age restrictions. And the whole purpose is we bring those students, we organize as a university, we organize those fest, Cyber First, where we call those girls at our campus. We give them an understanding what sort of infrastructure we have. We play with some cyber hacks in forms of games and so on. Yeah? But we also go sometimes to school level, 4th standard, 3rd standard, 2nd standards, and then talk them cybersecurity, but not in technical way, but more on simplistic way, just to give them more awareness what to do, what not to do, if they have access to the, for example, mobile phone, how you help them guiding what to do, what not to do. So they are kind of creating this as a habit, infusing it in their culture, so that when you grow up from 2nd standard onwards up to college level, you get a sense what is cybersecurity. You understand what are the hacks, what is phishing, what is spamming, and so on. So it's not like you have to go in technical to understand things, but just kind of basic understanding, awareness will help you. When you get to hear from time to time people, you visit certain universities, campuses, you get a lot of sense. You play with, in terms of games. Through games you learn a lot, because for kids, you can't really teach them kind of lectures. You can engage them in the form of games. So you create certain games which are cyber related, gives you awareness, understanding what to do, what not to do. So, but apart from that, we have something called Industry 100. So UK government also pushing cybersecurity, attracting small businesses who work on cybersecurity, can lead cybersecurity aspects. So they have a group of 100 companies which are kind of focusing more on cybersecurity. UK government also released some cyber assessment framework. If you are a company, how can you assess your cybersecurity understanding of the organization? So they have certain standard framework, anyone can use free of cost and so on. And of course, cybersecurity is a very big thing, because the government is promoting it very seriously, and in fact, UK is one of the leading countries in terms of cybersecurity. They also offer something called NCSC certifications. So as a university, we have, we call BSc and MSc there. So we have BSc in cybersecurity and MSc in cybersecurity. We have both courses certified by NCSC. So when they certify, they say whether it's a gold, it's a silver. And one of the requirements for gold, fortunately we have gold, one of the requirements for gold is you don't just teach cybersecurity to the students of cybersecurity. You have to introduce cybersecurity at the university level. Yeah? Even in a simplistic way, we have people from business, we have people from other engineering and other department. They have some fusion of cybersecurity in their curriculum, so that everyone can understand basic cybersecurity aspects. Obviously, if you need more technical detail, then there are people who are experts who are learning cybersecurity in more details. Yeah? So that's how they are promoting cybersecurity at all levels. And obviously, they have a lot more kind of guidelines. They release, similar to this, they release guidelines on phishing, how to strengthen your password, what is zero-day attack, and so on. So you can easily. Now, when I'm talking about phishing, I just wanted to highlight some of the work that we are doing currently. Some of the works are funded from defense and government, so I can't really reflect in terms of solutions and so on, but that'll give you a sense what we are working on some of the projects. So one of the project is social engineering phishing email detections. So we got to see a lot more phishing emails, how you detect which of the email is phishing, how you can kind of create models, machine learning models that can help you doing so. And one of the trick that we use, solution is used with something called feature hashing. I don't know if you heard about it. So we use hashing technique to this. What is hashing? Right. So it's rather than looking at the index, I have a certain feature from data set coming from different companies, or so you're collecting data set first of all. So rather than looking at the index, because when you match it, whether this email is phishing is based on certain characteristics, it computes the hash value and then computing hash where it finds, rather than you have indices where you can store everything in your database and then you are matching those indices. So it's a kind of a bit efficient method. We are also using NLP to reflecting how the decisions are being made, how you can contextualize this in the kind of human aspect. So obviously the standard process, you got a data collection. Once you collect data, maybe the data is not ready to process. Yeah, because you are detecting spam. So how you define spamming, right? Sometimes you have to also correct the words. So you got sentences, you break down it, extract the tokens, words. Yeah, within the words, you have to sometimes make it correct in a sense. For example, caring. So you have to convert caring to care, yeah, and so on. And then similarly, and then you have certain keywords, or maybe you can use data set of phishing email, yeah. So those keywords, URL, whatever is the process, you match those things from your data sets ideally. Now, how well you can optimize this, what should be, how well this process can work on the scalable system is kind of depend on the algorithms and the machine learning. So we did certain tests. For example, you look at the holistic process. We got data. You apply NLP to filter it. You apply feature extraction. You train. You divide your data set in training and testing, and so on. And then you kind of train and test it. Yeah, what does the accuracy look like? So we did certain experiments, like once you do the holistic things, then you try to see if you can optimize some of the intermediate processes. Yeah. So for example, you look at this training, you try kind of play with around how you divide training and testing samples, and what kind of samples would be good enough to carry. Whether your database is balanced or imbalance, yeah, whether it's undersampling, oversampling, and so on. I'm not going into detail, but I believe my colleague from Jammu has covered kind of machine learning in a good detail, so I'm not going into detail. But then you also look for what should be the volume of your data set. You also look at what sort of features you will consider. So let's say if you get 50 features, whether you want to go with all 50, you want to filter those features, play around this to see which combination of the features will optimize your results. Yeah, so you all play around this and then come to some solutions. So we are kind of did something and we come up with some solutions. Again, this work is still going, so I'm just not going to focus much. But then it seems to me that this technique is better in terms of, so it's a storage vector size reduction is only 8% of the original size, and then twice as fast as the traditional method. So it seems to be this is really promising method, but we still need to kind of play around this. Second could be example of understanding phishing websites. As I said, traditionally it was okay. So what is a phishing website? Generally what was happening earlier, you have a website, we understand whether it's a phishing or not. Most of the time people look for HTTPS. Yeah, what is HTTPS? It's a secure hypertext transfer protocol. What is secure here? How does it secure? So mainly it says whatever transmission or data exchange being taking place from this website connecting to a server or whatever, it's using something called SSL, yeah, secure socket layer or transport layer security. So your data is already encrypted when it leaves and so on. That's why it's considered safe. But now what if someone come with a very similar website with a kind of fake content? Content are also same. I have come across with this. Actually, one of my friends dropped me an email saying, I got an offer from Dubai. He didn't even apply. And then he sent me this saying, this is the web link you can go through. Because generally we don't remember the web link. We don't remember the website address. So when I click on this, I find all the pages are exactly same as the legitimate website. Exactly same. What is different? Contact details. And they were saying, oh, we can manage your accommodation, everything. You just pay some amount so that we can, reserve it for you. They were asking for 50,000, something. So this is a kind of tricky game. And it was not as difficult in the past because when you look at certain things, you can kind of crack it. Now it's more organized. It's really, really hard for you to understand what's going on. So some of the examples could be, obviously, URL shortening. Nowadays, there are websites which can shorten your URL. Yeah? Rather than posting the whole URL, if you pass your actual URL, they will give you a shorter URL. And generally what we post, whether social media or whatever. Now, how do you get a sense that this is the correct address, even if you know the address of a website? It's kind of impossible to understand without clicking whether this is a legitimate site or not. Yeah? So things were made and being made in a good way, but people are misusing it. The whole point was rather than people to remember the whole address, it's good to have smaller address so it's easy to, yeah? Yeah. Pop-up windows, we all know. Sometimes you are forced to enable those windows in order to complete certain things, but then there are websites which will by default enabled. There are URL which redirect you. Once you go to a site, press enter, it will automatically redirect you to another website. And you start believing that this is the same website that you're going through. There are certain symbols people are using. So sometimes really, some websites really use long URLs. Yeah? And in that they have a space, underscore, @ blah, blah, blah. So there are cases where it says dashes in URL can be used to mimic a domain. So for example, if you look at here, which I can't show here, https fake-book.com. You might say this is Facebook, you just go there. And actually all the pages are same. There's a login page where you log in, put your user ID and password. It will say incorrect. But the actual website has captured your detail. And it will go to the actual website, put your user ID password, and change the password. And hack your system. Yeah? Similarly, Facebook.com and then @ some other site. So what it does is, it will go to Facebook.com, but then redirect to the other website actually, automatically, without knowing you. So that, these tweaks things which generally people don't recognize because we are not trained that this is what is going on. That's where it's really important to have these kind of awareness. This is not really technical, but then sometimes it's impossible or very difficult to understand whether you are a legitimate or a fake website. Now, one company came with one of the solutions. They said, on our website we will put an image. If you see that image, you consider you are on a secure website, which may not work. Because then as an attacker, I can also copy that image and put on my website, isn't it? So what they come up with saying, when you log in, what you do is, I will show you a group of images, and you have to pick 3 images with a certain sequence. So next time when you go, you'll get to see 8 images in a frame. You have to click what were the 3 images you selected at the time of registration, and what were their sequence. As long as you are correctly doing those with your user ID and detail, then you will be logging. Because the fake website may have some images, but then it doesn't work the sequence. Sequence is the thing you only know of the database. Yeah, so those kind of solution might work here. And then what is Favicon? Yeah, so when you say google.com, in front of the address bar there's an icon. Most of the companies have started doing this. It's called Favicon. This was introduced claiming that this will kind of identify that this is the actual legitimate website, but kind of may not work. Attacker can also use the same, copy it on their website, and so on. And obviously, there's a web page's content. There's a lot more malicious script, URLs, and dodgy things, and they intentionally ask you to claim it, to click it, and so on. So again, you can do the similar work in a way, train your model that can efficiently detect. But building those models, you need to understand the complexity of the attack scenario. You can't just simply say and pick one data set that's having malicious URL links, and you say if your link is one of those, it's a phishing, otherwise not. So now understanding problem itself become complex. You have to understand what are the different ways attackers are using to create phishing content. Yeah? You have to feed this into your system, obviously, in order to process your system to understand all these things. And there only you can develop those kind of effective solutions against these ongoing threats. We are also doing some work around federated learning. What is federated learning and why we need it? Yeah. Spoofing and phishing are two different things. So phishing is what? Somebody is phishing you. Phishing is like, I don't know if you've seen this meme or the video where there's a mother who is feeding her child. And when the child opens, so he's showing the chocolate, and as soon as that girl opens the mouth, put the spoon. That's a phishing. Yeah? You're showing something, but actually it is something else. So that's what phishing about. Phishing email, phishing messages, and so on. Redirect you with something else, which is malicious. Spoofing is something you are fabricating something. I can spoof a message or email that seems to be coming from legitimate source. So let's say if the email is, say, director@nith or .ac.in. I can fabricate an email and send the message with the same email. That's called spoofing. So there are tools that can help you to fabricate, to create messages from those emails, which are kind of seems to be legitimate. And you will start believing that this is the actual email because it's coming from this address. But it's not been sent by an actual person. Yeah? So what kind of solution we can have for that? It can happen, but for website, it's still difficult because somehow your website hosting somewhere, having a domain name, so maybe those kind of information, and you have an IP address. Again, you can also do IP spoofing, but kind of a group of characteristics can help you identify things. But in case of email, for example, if it is coming from the same address, which say director@nits.ac.in, how will you get to know that this is a fabricate, this is a fake email, not the actual email? Yeah, so we'll do one of the exercise in tutorial to understand that. Something is called email authentication. We'll do that. Okay, so what is federated learning? Yeah. So as I said, one of the problem with traditional learning is you need data to train. You need to have actual access to the data. Yeah. Now, there are certain applications and sectors, for example, healthcare, finance, where companies don't want to reveal their data. So what they will, and of course, for example, I'm talking about 5G here. How is this 5G different from other generations? One of the key differences is 5G network allows multi-vendor thing. So it's a radio access network. It's an open network that wirelessly connect. Yeah, so how does your mobile system work? When you turn on your mobile, what it looks for? Nearest tower. So we have certain control channels. So those channels get access. They start scanning, and then try to see which is the nearest tower it can connect to. If you have a Vodafone SIM, it try to connect to Vodafone SIM, and so on and so forth. Yeah. And in background, it does authentication, which you don't kind of, maybe as a user we don't realize, but it does kind of authentication to see it's connected to the right network. And that's what it get to see. If the Vodafone and Air tower next to each other, how would your system mobile get to know which tower it has to connect based on the authentication where it can connect? Yeah. So similarly, again, in 2G, 3G, we were having kind of very less vendors, and most of these systems were vendor specific. There are very few companies. Now it's kind of in 5G. The way it's been structured, there are a lot of involvement in different vendors with different devices, different level of devices. So you are talking about different types of devices. Now, one of the difficulty with this is different manufacturers and vendors, these devices run different protocols. They collect different data in a different format and so on. So it's not straightforward to connect all those devices and you can collect your data. It's not going to work. Sometimes those devices also have certain constraints and so on and so forth. Yeah. So in a simplistic way, if I say the vendors do not want to send their data, what they are collecting, and as a company or utility owner, whatever you call, we want to do some computations over it. That's where federated learning comes, where you can, as an organization, you can train your model and then share your model with the centralized body. So all the companies will train their whole model with the data, send the model, not the data. And then that centralized body will compute the global model. And that's how they learn patterns, and the global model will adopt it. Yeah, what is the acceptance? For example, if I divide the country into northeast, west, and south, 4 zones, everybody has their own data, their own kind of system. You can train those local models and then create a centralized model that can accept all types of data, all types of protocols, and so on. Yeah, without sharing the actual data. So that is where federated learning comes in. And then people also start talking about cybersecurity aspect of the what if data is malicious, what if someone compromise your local model, what will happen, and so on and so forth. So again, as I said, we did some kind of work around this. We also introduced something else called differential privacy. What is that? Huh? Privacy technique, but what is differential? Anyway, we will be talking about in one of the, I guess I have one of the slides, but just to touch here. What is differential privacy? And what's the use of it? Have you heard this term? No? Okay, so differential privacy is something, sometimes it's been said, oh, if I need to share my data with someone, generally we say privacy should be protected, individual records should not be revealed. So maybe I can anonymize the data, I can remove person name, ID, whatever, and simply send the actual data. So that is something we call anonymous data. Someone can look at this and they will not be able to identify the individuals from looking at that data. Yeah. But sometimes we also don't want to send that actual data to the system. Yeah. For example, if I need to send 100 rupees to you, but I don't want anyone to know how many money I have sent you. Actually, I can give you 500, and then take you whatever remaining I want. That is the differential privacy. So rather than sending 100 rupees, I will introduce some noise to the data. So my data values, actual values will change. Yeah, and then you feed to the system. So the model don't learn the actual values, or it learns the pattern rather. And then the company that you are sharing your data don't hold your actual data. Yeah, so that is the purpose of having differential privacy. Okay. So as I said, we are also doing federated adversarial attacks on federated learning, considering what if there's an attack on your models where someone has created your benign data to malicious, or the other way. If there's a malicious data, but then your models start believing this is the legitimate data. So those kind of attacks, yeah.
Differential privacy also there, and another techniques also there, like common encryption. So shall we know in which aspect of?
I will be talking about homomorphing as well in one of the lectures, very briefly. Then we can talk more. So as I said, the whole point here, let's say you have a machine learning model, you have your local model, you have a global model, everything is working fine. But now as an attacker, I compromise one of the local model, or maybe data. I manipulate data, and your system doesn't know, maybe in a way. Or rather than data, I can target model. Yeah, because model is the thing you're sharing. I target the model, start believing this model that this pattern or this data is legitimate. The way I will tweak your model. Or the other way, if it is actual data, I will say it's malicious, or if it is malicious, I will say it's a benign data. And then you train your model and see how does it work. Does the kind of research we are doing try understand what should be the size of the data that we are infusing, malicious data infusing to the system, can actually make the difference, can actually start believing the system that the data coming through is actually legitimate. It doesn't understand that this is malicious data, and so on. Okay, so I thought maybe I should give some brief understanding. Let's talk about cyber physical, some more terms before we go for a quick break. So what is a cyber physical system? The three terms we see: cyber, physical, system. Cyber, we are talking about cyber security. Physical systems. Generally, physical system means it should have some part physically, some devices, some sensors, actuators, something. Yeah, we call them physical part, or maybe some devices, hardware setup, and so on. Sometimes when we say system, is not a simplistic system. When I say power system is really a complex system. This is a system of systems. There are several subsystems within the system. Yeah. Depending on how you see, I'll have a slide to reflect the whole power system. How does it look like? So it has units called, for example, generation unit. Different mechanisms how you generate power, electricity. Mechanism to transmit that power from generation unit to substations. Mechanism from substations to your home or to the industry, and so on. You see there's a certain voltage requirement for home, 220, 240 volt, 110 volt, and so on. Yeah, so there are certain processes involved that will lower the voltage, up the voltage, and so on. And this is one of the examples. But then you might have smart meter at home. Smart meter also kind of giving you electricity, connecting with the control center and other units. So they have several subsystems within the whole power grid. Similarly, transportation, whatever system you think, they all are systems of systems. They have several subsystems that are working together depending on what applications we are talking about. So cyber physical system, generally you see physical part as a sensors or devices that are used to control, collect data, and so on. And then you have communications. So let's say you got sensors. Sensors, what they do, you got actuators. Sensor collect data. Actuators help sending data through some mean of communication. Maybe Wi-Fi, maybe Zigbee, maybe 5G, depending on the application, how long the data should be sent. Yeah. And then once you collect your data, you run this data through the system, make certain decisions, and based on whatever your outcome, you decide what to do, what control action you need to take. So that's what is cyber physical system. Now there's another term called IoT. How do you see IoT? What is IoT? Internet of Things. What does it mean? Yeah. Now what we have is smart devices that are on the internet. Yeah, they're collecting data, sending data, and so on. So that's what we call Internet of Things. How Internet of Things different from cyber physical system? Are they same thing? Are they different things? If I say I have an IoT system versus cyber physical system, are they same things? Yeah. So I can say maybe IoT system is a part of cyber physical system. Because in IoT system, you have mechanics. So generally it's been saying there are 3 layers of IoT architecture. One is called perception layer, where you have sensors and actuators and so on. You have transmission layer, some mean of communication, and you have application layer feeding back. But then within the application layer, it doesn't elaborate more, where it lacks with physical system. In physical system, we pass the data that we collect to physical systems to understand what will happen to the system. Now I'm collecting a data from a sensors, and I'm modifying some of the data in that. What I want to pass that data on the physical system, whether I want to see whether it will work or not, how it will react, what kind of impact I see on the physical system, which generally you don't see in IoT system. So the difference, I would say, in terms of operational risk. So if I consider as an individual, I say I have a smart camera. Yeah, smart camera can automatically take pictures every 5 minutes, whatever, and send me on my email, let's say. Yeah. When you talk about individual device, it's not a system. Someone hack it, what will happen in worst case? They can get the picture. Yeah, that's it. Might be useful for creating attack scenarios, gathering information, but it doesn't have any direct impact on the system I have. Yeah. On the other hand, physical system, you are part of that system. Operator sitting at control center, if you hack them and they get into system, they will, whatever changes they will make, either they will inject malicious data, run certain malicious command, it will directly impact the physical system. Lines will be overloaded, underloaded, some devices may be burst if it is kind of overloaded and so on. So physical system have direct consequences. There's a train running, someone control their brakes. What will happen? So physical system have a lot more adverse consequence that could be life-threatening as well. There's a manufacturing plant. Someone controls big machines. That don't stop. Maybe it will harm people. So most of the physical systems have safety issues. We'll talk about those sometimes. So again, you got sensors. Sometimes now we are talking about digital analog systems. You got sensors, the sense data. You got analog to digital. If it is a analog sensors, in order to feed it, you have to use one converter from analog to digital. You pass this to your digital system, process whatever, make certain decisions, and then when you need to take action, you need to convert digital to analog, and then send your control command to control it. Yeah. Apart from cyber physical, there are also kind of some other systems, we call it enterprise system. Now, I guess we will be talking about, I have a few slides. How does IT system is different from cyber physical systems? Now, these kind of systems also called operational technology, OT. IT is called information technology. So information, I'll be talking about that in more detail. So enterprise system, basically we are talking about IT system, organizations, government offices, universities, companies, generally run on IT systems. What kind of infrastructure we need? Computers, laptops, internet. Yeah, you're sending data, collecting data, that's it, generally. Physical system, as I said, it's a physical process, physical services involved in that. Then you have social system, government social system, healthcare community, educational community, social media community, and so on. We're also collecting, sending a lot of data around it, which might influence people, not directly, maybe indirectly. What if capture someone photo, edit it, and post on, so those kind of societal issues are there. And then you got some biological system. What if so in the UK and whole European Union, healthcare data, finance data are considered really sensitive data. Even the hospital cannot reveal that information. Somebody is suffering for disease X, cannot be revealed to anyone. If something like this happens, there's a huge penalty for company to pay. It's really huge. So these data are really sensitive. If you're working on those systems for security, machine learning, whatever, for whatever purpose, you need to be very careful what data you are using. Does this data that you're collecting violates any of those rules? Obviously, you have to protect the privacy, training your models, and revealing it. Yeah. So it also look at when someone release AI model, it should not also revealing patterns. Yeah, in a way that can help to identify individuals directly or indirectly. So these sectors are really kind of sensitive to work on, and you need labels of approvals to go around what data you are collecting. In the not about this data, but in general, European Union have a regulation, something called GDPR. I guess India has also come up with something similar. What is GDPR? It's a General Data Protection Act regulations, which says if you are a company and if you are collecting data of citizens living in European Union is 28 countries, I guess, group of 28 countries. You are responsible and liable to collect, to follow certain regulations. What data you can collect, how you will store their data, how you will delete their data, when will you delete their data, how long you will keep your data. So they have certain regulations that you need to tell the people who you are collecting their data. Yeah. So many of the companies don't bother it. For example, Make My Trip, all those, Yatra, something. If you open in the UK, it doesn't work. Because they don't want to have this hassle. And one of the difficulty if you're collecting data, let's say online payment system. You have a website where you are selling online products around the world. Of course, people from UK and any other country can buy that product. And you are asking them to pay through credit card. You're storing their credit card detail in a way. What if that data reveals? If that data reveals, you are liable to pay that fine. And the fine is it's a hefty fine. And in the UK, they also have something called ICO, Information Commissioner Office, something. If there's a data breach happen to your organization, you are liable to inform that there's a data breach. Because if they figure it out, that there was a database and you haven't reported it in the first place, there's a huge fine. There's also fine if there's a database, unless you are not following their guidelines. So if they say you have to put in place these kind of security control, and you have all done, despite of that your data is compromised, you're okay, because you're following those things, and obviously there's always chances that someone can get in. But if you're not following the regulation, you've been attacked, you're liable to pay hefty fine, which is 4 million euros, something. It's really high. It's hefty fine. So the government is really serious about all those things. You cannot. It doesn't work like you can, do these things and thinking you will bypass the system. You can't. And that's one of the things. That's where these systems are really working there, because rules are really tight, penalties are really high. You can't think of afford those penalties. You can't. Yeah. So those kinds of working on those kind of systems, each of these systems bring their own challenges. Depending on where you are living, what kind of people, what kind of systems are around you, and that's where when you develop security solution, AI models, you need to take into consideration all those aspects. Then only you can customize your solutions that can handle and address the problem in that context. Yeah. What could be the example of cyber and physical attacks? So again, I'm saying physical is actuator, sensors, computing. So there could be information leakage, authentication failure, and deadline misses like you don't really able to do in time. So sometimes there are requirements that this data need to be sent from device A to B in milliseconds, for example. Yeah. And of course, in terms of cyber, mostly. So most of the people that one of the misconception, I wouldn't say misconception, but most of the people who are from cyber security or computer science background, for them cyber attack is on communication. Yeah. When we say cyber attack, people think over the network, you do. That's attack, which is okay. But cyber physical system is not just about that. One of the things as an attacker, your intention is to harm the system. Physical system, not just to compromise data, or not just compromise communication. If I'm able to compromise the system, manipulate data, and keeping value from 100 to 10,000, it doesn't harm system. My system is still okay. So as an attacker also decide on sort of design the attack in a way that can hamper the physical system. And that's where the impact of attack is really important to understand. I'll be talking about all those things in more detail in the next lectures. Do we want to have a break? Let's have a 5-minute break. It's 12:45. Let's come back 10 to 1. Yeah, 12:50. 5 minutes okay, or 10 minutes? 10, okay, let's go at 10 minutes. So come back at 12:55. We'll continue. I will be a little quicker this time. Right. Shall we continue now? Okay, so one of the things when we say cyber physical system, we have talked about physical attacks, we have talked about cyber attacks, but then there are also dependencies. We're talking in more detail. But try understand, there might be possible I can perform a physical attack, but then can impact the physical cyberspace, or the other way, I may perform a cyber attack that can influence the physical space. You have certain policies for cyber, how you handle cyber attack, certain policy how you handle physical attack, but they might be interlinked. So when we design policies, we also need to make sure we understand both policies and how an attacker can utilize those. Because generally, in an older system, when we say physical security, it means simply tampering. And you have guidelines how not to tamper the physical devices. In cyber, generally we say how to protect data over the communication. But now what we are saying is, you not just have to protect data. Protecting data is not necessarily as much as protecting the physical system. I'll be talking about in some slides how it's different. Okay, so if we look at this figure, unfortunately this doesn't work on the screen. Okay, you see cyber, you see critical infrastructure. There are a lot more attacks being targeted on CNI compared to other non-CNI sectors. And if you look at the biggest threats to organization, you see social engineering on the top, insider threats, advanced persistent threat. What is advanced persistent threat? Quickly. What is APT?
It's like it stays like when it have occurred, it stays for like for a long time.
Right.
For a long time, yes.
Okay. So when there's a traditional virus in the system, we have IDS or antivirus. Yeah, your antivirus can check, say, oh, these files have been infected, and they will put into quarantine or whatever, remove it from the system. So it's easier to detect those kind of attacks or malware, I would say, in the system. Well, now what is advanced persistent threat? It takes time to execute. So in a very simplistic way, it gets into your system. So your IDS should not detect it because there's no malware ideally. So it looks for bind. How does the antivirus work? What it detects saying there's a virus, what does it mean? So it looks for signatures in a simplistic way, patterns of strings. No, it looks for, so for all the virus, it's a code. So kind of string it matches, saying it could be this kind of virus, remove it, remove those files. Now in this case, as I said, attackers inject simple files in the system. It doesn't have any symptom of those strings. So whenever IDS will check, saying everything looks fine. But what it does, since your system is connected to the internet, it will connect to the internet and download the latest version, yeah, which has malicious content in it.
Sir, can we take Pager's attacks as an example of last time? Pager's attacks on Hamas. Can we take this as a APT attack?
Pager's attack, what happened? What was that?
I mean, last time this kind of attacks was occurred, like Pager's attacks between Hamas and Israel.
Maybe yes,
Yeah.
because those kind of attacks are now being more popular. Popular in the sense they will bypass your IDS, traditional IDS. So intrusion detection system cannot detect them. And once they get into system connected to the internet, they will load, fully loaded with malware. And then malware has certain conditions to execute. It will not execute on the go. It will look for the target device, which kind of device it needs to target. Sometimes you have your device is connected to the whole network. Yeah, so let's say in this university, I have my laptop connected here. But as an attacker, I want to target a server where the financial data is there in the university. So maybe this is the easiest system I can get into because it doesn't have IDS, for example. So attacker can get into the system, or maybe you have basic IDs, intrusion detection, whatever, antivirus. It will get into system, sit there. It will say if this device is connected to the network, maybe that attack can propagate to other devices. It will kind of load it, start propagating until it reaches to the destination, which server it's targeting, and there it will start harming. So even if it's going through other devices, it is very difficult to detect. Once it gets to target, start executing, triggering, and then harm that device. And that's why these systems, these attacks are really difficult to detect. All right, then we got unpatched system, malware, DDoS, ransom. We know ransom, yeah, ransomware attack. Then got mobile malware and others. Okay, in OT system or cyber physical system, there's a popular model called Purdue model. In IT system, we have something called TCP/IP. We have OSI model. I guess all of us know that, yeah? OSI, TCP. So in OSI, for example, we have 7 layers, physical, data link, up to application. Similarly for OT system, so the way it looks like, this is your communication label, communication layer. This is your basically physical and operational, and this is D and Z. What is D and Z? What is D and Z? D and Z sometimes people call it. It's a demilitarized zone. What does it mean? And it's a link between IT system and an OT system. I'm calling this OT system, and I'm calling this an IT system. So generally in, for example, power plant, for example, they have some part of IT system because they need devices, people who look for monitoring certain things. But then they also have physical operations, a lot more complex power devices, communication devices, and so on. So they have 0, 1, 2 label. We call this Purdue model. 0 label means we are talking about field devices, sensors, actuators, all those comes here. Then you got controller of these devices. Yeah? So sensor will sense data, send it somewhere, and we want to control what data we want to collect, how long we want to collect, and so on. So you got a couple of devices. Then you got HMI or supervisory label, where you control these controllers. Yeah? HMI is human machine interface. As a human, you can set, reset things. And then you got control center. So let's say this is example. Now if I'm picking an example of smart grid, particularly let's say substation. So on substation, you got sensors, you got devices that sense power measurements, you got supervisory control which says what value should be capturing, what is the level of those values, whether everything looks okay or not. If not, you control, up, down voltage, current, whatever. Then you got operational management, where you got human machine interface, application server, database server, but they all are part of this system. You're collecting data, maybe storing somewhere, doing some analysis, and so on. On enterprise zone or IT zone, I have domain controller. What is the role of domain controller? Domain controller is the one that caps all the credentials. Now we are talking about a centralized systems. I don't know if it does it. So when you go to your university website, what protocol it use? So for example, when I use my laptop, which is the university laptop, if I connect here, I'm connecting to the centralized system. Again, they have divided the centralized system in 2 parts. I might not need to log in to certain part of the system once I'm logged into one website. So university have their own subsystems within that. Yeah, some systems force you to log in again and again, but some systems may not. I'm not sure how does it work. But so that is the concept of something called Active Directory. What is the role of Active Directory? So let's say if I have a system here which is not connected to my centralized server, centralized system here. If this is kind of compromised because it doesn't follow strict policies that university follow in terms of securing your system. Let's say we have, your system should be updated in every week or every month. You should be using strong password which looks XYZ. If my system is connected to the centralized, we have a centralized policy that will enforce every other system. Even if I don't upgrade my system, the centralized system enforce it to restart. It will say there's a time to patch. It will give you a time saying few days if you want to do now or tomorrow or day. But at some point it will say now it's enough. You have to do it now if you don't do it. So it's enforcing you to follow those all systems. So in a way, domain controller is one thing where you keep all the credentials, passwords, VPN passwords, keys to how you access devices and so on, all the passwords there. Then you got web servers, other servers, and then you got internal DMZ, web server, emails. Now, again, we will be doing one exercise in tutorial to understand how to decide on which device to place where and why. So we'll do some exercise. I'm not going to detail that. But the whole point, now we got DMZ. Now DMZ is something that talk to the external world. So as a company, you have all kind of devices. Some devices that are internally, you don't really need to connect to internet. Nobody wants to fetch that data out of the country, out of your organization. But you might have some systems. For example, you have a website, you have a web server. Yeah, you have an email server. You want to interact with the external world. So you have email server. Those servers should be placed in a way they can interact with the external world. You have to be careful what kind of security will be there compared to other devices. I have a number of devices. I have 10 devices. My 9 of devices are not connected to the internet at all. I need not to worry about cybersecurity of those. But if one of the devices is connected, I'm worrying about. But I will also make sure that they are placed in a different zone. It should not be like that once attacker can connect one of the devices, this is connected to the internet, then they can jump to the other devices if they're in the same network. But I will make sure that device is in a separate zone completely. So I know I need to take care of these devices which are connected to the internet, this zone rather than this zone. So it's a very kind of similar thing. So you decide on what part of the system is external to the world. So you want to have different security solutions and label for those, but then other devices which are not connected to the internet, you don't really care. Yeah, so that's how it looks like. So we call it level 0 physical process, level 1 intelligent devices, sensing, level 2 control system, and then you got manufacturing operation or supervisory operational system, operation management zone. Then we got a demilitarized zone, and this is kind of IT systems. Most of the IT system you do use VPN, or they have their own forcing encryption policies and so on. Now it is also called that cyber physical systems collect time series data. What is time series data? I'll be talking about all these terms because when we talk about the other lectures, I'm not talking about all these things then. I believe that you understand all this basic information, and then we talk about how to kind of what is the problem, what are the solutions, and so on. What is time series data? Simply sinusoidal, like, yeah. Time series data simply says, I want to understand behavior of a variable over the time period. Yeah. I want to understand in 1 hour how many times stocks go up and down, for example. Similarly, you want to, and then frequency, current, voltage, they all go up and down throughout the day. So we want to understand how these values behave over a certain period of time. So I can get a sense in daytime, like peak time, let's I'm saying peak is my day and then peak off is my night time. I want to understand what is the power requirement in day, what is the power requirement at night in this region or for this institute, for example. Time series data will help me to understand how you define day, how you define night, what is the hours, and then based on that you get to see what is the consumption level in daytime and in nighttime. So this will help you to understand time series data. Yeah, over the period you can then decide what period you want to analyze, and based on that you can do your analysis. There's something is called cross-sectional data, which says at this point I want to understand how many variables are impacting my system. Rather than over the period, I just wanted to know what is the condition now. What is the value of this variable at this point? Or how many variables are there that can impact my system as of now? Yeah, so that's the kind of basic difference that we see. Now, talking about the layers of cybersecurity. So generally there are 7 layers considered. Outer layer, very outer layer, human layer. Generally there's a saying called humans are the weakest link. Because it's easy to target human versus machine. If you put a code in machine which says don't allow X, Y, Z, it will not allow whatever happens. By humans, you can influence them. You can tell them a story, what happened, you show some pity, you create a scenario, this is what happened to me, show some sympathy and blah, blah, blah. Humans might influence and they may allow. That's one, and then in cybersecurity particularly, there's a saying like says, you target those people who are not cybersecurity experts. If you want to target an organization, you go to a receptionist, you go to people who really don't have understanding, but they're having system to use. You can influence them much easier because they don't have understanding what is phishing, what is spamming, what is what. Yeah. On the other hand, people who have some understanding, it's difficult because they will identify, they will apply some logic. So if you need to target an organization as an attacker, it's easy for you to target people who don't have cybersecurity expertise and customize them. And that's what I'm saying now. It's very difficult to detect those kind of attacks because attackers are customizing. They are planned attack now, organized crime, where they can customize the message. Even the experts cannot sometimes identify whether this is a phishing or spam. Yeah. Human layer, then you got perimeter security. What is the boundary of your infrastructure? How you're defining your boundary and what kind of security you want to have. Now we are talking about large scale systems. We can't protect countrywide infrastructure. It's impossible. Protection, security is all about costing. You want to place solution, how many solutions you can put in place across the country? So you have to identify what is your secure perimeter of the organization, how you're defining your, that's why there's a kind of importance of segmenting your network. Yeah, so that you know which part of the system is secure, which part of the system may be not secure, where you need more attention and so on. So you segregate it. Network security, mostly people, again, network security is not new. People have been talking about network security since very long. But now the behavior of the attack have been changed. Now they are more stealthy attack. So let's say you have an intrusion detection which says if the payload is more than 1500 bytes or whatever, it will classify as an attack or threat. If the IP is coming up from one of the blacklisted IP, might be threat. Yeah. If the port number is open, whatever kind of basic IT that we used to do. The way this has changed is, as I said, now the attack is more sophisticated, more stealthy attack. They know how to bypass. They are designed to bypass your IDS. So traditional method will not work. You need to apply a lot more intelligence than just the tool. Yeah. Endpoint security. Endpoint security simply, if I have a connection from here to there, I can put encryption over the network. So we know my whatever data I'm sending is encrypted. But how are the points? How are the devices which are sending and connecting data? If I'm introducing some data to this device, it can send my malicious data over the network in a secure way. And my malicious data will be received by the recipient. Yeah? So that's what is endpoint security. How you identify which of the devices or what part of the system having endpoint and what kind of security you have put in place today. Application security, depending on the number of applications you have, what data they are generating, you talk about data security. Now data security, we say data in transit, data in rest, data in motion. Yeah? When you're storing data, what kind of security you should have. When the data is being transmitted over the network, what security you want, and so on. And then you have mission critical assets. So within the large infrastructure, how you identify which of the assets are critical for you. You means infrastructure for your organizations. If I have 10,000 devices, I might not be in a position to secure all the devices. But what I will do, I will identify out of these 10,000 how many devices are there which are critical. If someone target those devices, if those devices don't work, how this will impact the physical operations. I will identify those devices and pay more attention to those devices rather than everything else. There might be one device. If someone attack it, I have a replacement. I have backup. I don't really care if you attack this, because maybe this part is isolated. Even if you connect all the devices, I still have backup. But there might be some devices which are really expensive, like servers, for example. You don't have many servers. Generally, university have organizations have 1 or 2 servers. What if you compromise the servers? You possibly are compromising all the data and so on. So we need to identify which are the critical devices and kind of thinking about how you protect it. Now, in terms of maturity models, I'll just go quickly now. One thing is called, so there are 4 levels. One say unprepared, reactive, proactive, anticipating. Unprepared, when somebody attack your organizations, you don't know what to do because you don't have security and control in place, or maybe you have just basic controls. And you don't understand what kind of attack it is, what is APT, and so on. Reactive says you have something in place. You react when someone attack. If no, you don't really care. Proactive says, I want to be prepared. I want to understand what kind of cyber risk my organization has, and I want to see what kind of security control I have. If someone attack with attack X, do I have a solution to this? If not, then possibly I would like to see how this will impact my organizations. If I can see there's a 10 attack that someone can target my system, out of these 10, I see how they impact my physical systems. If out of these 3 saying someone can control your brakes, someone can control your accelerator and attack, I should be more worried about those attacks rather than someone control your entertainment system. Yeah? So you decide on which are the more critical attacks to my organization, and I'm thinking about, do I have solution to this? Do I have enough tool technology to apply if someone attack like this? If no, I want to be proactive. I want to see what kind of solution I can bring in, deploy to my organization, which is more proactive. And then anticipating, like you prepare well structure for future as well. You're thinking your company is growing, you're deploying new devices and so on. So you're thinking in that perspective over the down 5 years, 10 years, how my system look like, what kind of security I will have. So you kind of anticipate about the futuristic of your system and then decide on solutions and so on. Let's skip this. Cyber hunting, again, it's been a difficult now. It's not been as traditional. Now we have, generally we call baseline normal behavior. So everything runs fine. I can see my voltage level should be this, my normal graph, yeah, for any variable. And then possibly you get to see new patterns. So maybe your IDS antivirus comes with some defined patterns, known attacks, and they come across with those, they can detect and flag saying there's an attack, there's a virus, there's a malware. But as we see every day, several thousand variations come every day. And there's also saying like antivirus companies also create malware so that they can sell their antivirus, isn't it? If their antivirus can secure the infrastructure, then there's no need to work on that. I'm not saying they are the one who do it, but they're just saying something like this. So then you can come up with new patterns, unknown attacks that you can't really understand, fluctuating your variable unexpectedly. Then there are certain tools that we need to use because they're having latest kind of technology. They handle large volume of data that manually we cannot do. Incident response, how are you going to react when system is under attack? Now more, I would say, effective incident response. So automating this process. When there's a malware attack my system, I should be, and it's changing some of the files, for example, running exe that should not be done, should not be there, and so on. My system should automatically able to understand what's going on and trigger appropriate responses to fix those, or at least mitigate the impact immediately and alert people, operators, to look into this, what's going on. Because the companies or the massive attack, larger attack that we talk about on cyber physical systems, they've been coordinated in nature. Coordinated attack when someone is targeting multiple devices, multiple systems of your organization. They're not just targeting one device or one type of attack. There are multiple type of attack targeting different devices. So if you pay attention here, you won't be able to do it. So we need automated process that can sense things and then start doing to mitigate it as much as possible. Possibly visualization. So if there's an electrical operator, if you ask them, look at the files, look at the logs, look at the network PCAP file, yeah? Maybe he won't be able to understand because he's not trained with cybersecurity. If I give you electrical, I'll show you, by the way. But if I give you power measurements or the way it looks like, what is bus system and so on, if you're not trained, you won't be able to understand those things. So one of the things is visualize things in the way people can understand. Visualization is much better. If I show you a graph, it's easier, much easier for you to understand rather than if I start showing you quantities of where, voltage divided by current, I squared divided, some equations. It's very difficult to understand equations, and then rather than if I show you graph, it's much easier to understand. So in a similar thing. Okay, again, I'll skip all this. It will take time. So incident response, as I said, preparation, detection, containment, recovery, and post-incident activity. Most of the time from previous attacks, attacker were targeting the system, and because we don't have enough tools, effective tools, we end up by not doing anything, and there's only post-incident analysis that you can do. What happened to your system? You start looking at footprints that can help you to understand things. But then incident responses, you have to prepare in advance. You can't simply wait and watch situation. You have to prepare yourself, build your detection strategies around APT and more sophisticated attack. Think about how you're going to do recovery if system is down. So in one of the attacks, the system was down for over a month because it's not IT system. It's not like this has been attacked. You can bring new laptop and you connect it. It's all about those complex devices that are part of your routine. Yeah, and bringing those devices, configuring, calibrating those devices, connecting it to the right takes time. So what is your recovery plan when someone targets? And then there's also called cyber physical social system, where people want to understand how the data, not just sensors, but also from people perspective, social systems can actually influence the physical system. So again, this is an example of cyber physical energy system. So what you see here is, okay, I'll just go and talk about things. Now, when I say energy system, energy itself is a very broad sector. There are different types of energy, that part of it, and smart grid or power grid is one of those. So in order to reduce carbon emission, Yeah, governments are introducing new way of generating energy, and one of the way is renewable energy. What is renewable energy? That does not have carbon emission in a way. Yeah. For example, we used to have petrol, diesel, coal, and so on, and they all generate a lot of emission, carbon emission, which is not good for the environment. So they want to promote renewable energy, so that they say, oh, there's a solar energy, geothermal energy, wind energy, biomass energy, hydroelectronic energy, marine energy, and so on. So there are different ways of generating, producing energy. However, these energy, we don't really know how much energy you can produce until you deploy and see. And how this can help. Obviously, year by year, our energy consumption is growing up. And the electricity that we generate as of now might not be enough. It's not enough as of now, but in the future. So there's a saying how you integrate different energy sources to the existing setup that we have, so that you generate, for example, wind energy, solar energy, and pass that to in one of the area as electricity and so on. Yeah. So how you can kind of reuse and send it to different part of the system as per the demand. Now, one of the difficulty is from cyber point of view. These, even if you are able to integrate, again, integration is another challenge. But we believe that at some point we have those, solar systems, wind systems, and all, and then somehow we are able to integrate all those into the centralized system. What about the cyber security? So currently we are talking about smart grid. We are just trying to understand how attacker can influence grid. Then in the future, might be we will be studying how attacker can influence solar system, a wind system. More importantly, integrated system. Is it possible attacker to go into a solar system and then target smart grid? Because they will be integrated in the future. Yeah, might be possible, but then understanding that how it's possible itself is too complex. So where we are heading towards are more complex systems, and it's not easy to understand operational side of it, and understanding cybersecurity is much difficult. In order to understand cybersecurity, you have to understand these systems, how they work, what devices they have, where the connections are, and so on. How these systems can impact each other. Yeah. So in the future, this will be a lot more complex system that we are talking about. And now we have, again, smart grid itself is as I say, countrywide infrastructure. So where we are kind of traveling towards much more complex systems. So definitely what we have learned in IT systems will not going to work here. We have to learn how we handle complex system, maybe a bottom-up approach, where you kind of have a bigger system and then you kind of divide and break down into small subsystems, try learn things, and then understand what are the interdependencies between those and so on. Yeah. So unfortunately, we don't have enough skills. Mostly people who work on cybersecurity, for them is like data security or IT security. Not many people understand these things. Therefore, it's really important to push these areas to do a lot more research, so that people can get into deep, do some experiments, give some better understanding. Should be feed into curriculum so that students from their undergrad, master can understand this is the future when you say smart city, smart systems. And then, because these are the sector will have a lot more opportunities in the future. If you are still working on web security, in the future you'll see a lot more jobs in this, and you are not skilled, you don't understand these systems. Yeah? Web security is already too crowded. I mean, the traditional IT system that people used to be. These are the systems will give you a lot more opportunities in the future. So it's really important for us to push ourselves and try understand interdisciplinary subjects more. Okay, just a few examples. So particularly in nuclear plant or a smart grid, you have something called physical layer. You go physical layer, where you have devices that are kind of being used to generate electricity. Then you got data acquisition layer. You got certain devices that control this part, and then you got servers that control this part, and then you have application layer where you can optimize and control things. So power generation, for example. So as I said, there are different sources through that you can generate power. But then power need to be transmitted across the country. It's a huge wise, country-wise thing. Power need to be transmitted from generation unit to a transmission substation. Have you seen the big towers in the field? Very big towers and wires going across, and it's saying it's too dangerous, don't 24,000 volts and so. And why it's like when electricity comes to our home, it's 220 volt, 240 volts. What does happen? How does its speed maintain? Why they have 24,000s and why we have 220, 240? I mean, we can understand might be the devices that we are using, they can't tolerate more voltage. That's why it's 220 or 110, whatever. Or why they have 24,000s? Exactly. So from generation unit to transmission substation, they have to travel a lot more distance. If the voltage is, what is voltage? It's all signal, travels in the form of signals. Higher the voltage, larger the distance they can travel. So they have to travel kilometers. If the voltage is really high, it can travel, and then you can capture that signal. Yeah, that's why those transmission lines are really high voltage lines, and you should not be touching them anywhere. And then it comes to distribution substation, where we got transformers, for example. It can step down the voltage as we need, and then be distributed to home, to businesses, and so on. So there are different devices. So let's say there's an attacker that can target your transformer. Your transformer is not able to step down the voltage. What will happen? It will blow out all the devices that you have. So these are the critical assets in the infrastructure. So we need to understand, and you'll be able to understand once you know what is transformer, how does it work, what's its role. Yeah. So there are other couple of other devices. Just something is called PMU, phase measurement unit. That's the device that actually estimate the magnitude of voltage, current, and phase angle. I don't know if you studied those things, but kind of basic understanding. Then you got IEDs called intelligent electronic devices. These devices generally microprocessor-based controllers, and they are used for certain purposes. For example, transformers, circuit breakers, and other key operators. So PMU measure the data, IEDs control that data. And they got RTUs, remote terminal unit. Those are the units, they capture that data and then send it over the network to control center, for example. Yeah. So let's say I have 5 substations, yeah, where you got different transformer, they are sending data, passing current, voltage to different units, household unit, businesses, and so on. As a company, I have a control center. I want to control, I want to understand, because you got the same grid. Yeah? Distribution are different centers. You have different centers, but the actual power is coming from the one source. You are distributing. So you want to understand what is going on in your infrastructure. So that's why you have control center. Sitting at control center, you can analyze what's happening in this part of the system, in this substation, that substation, and so on. When someone attacks your system, again, depending on how they are attacking, it might influence more than one substation. Yeah. So you have to have, this is what control center look like with the very large screens. You have seen that when they ISRO and they launch any new projects, you got to see the big screen where scientists are sitting looking at how it's big. In a very similar way, electrical operator, they look at the power quantities. which lines are getting overloaded, where's the more demand, less demand, so that they can manage the overall thing. IEDs, the way it looks like. Have you seen these? Maybe somewhere? Yeah? So these IEDs are for different purposes. For example, some to control relays, some to control transformers and others. And then you got different RTU devices. Now remote terminal units are the one they sends data from your substation to the control center. So all substations need to send data to the control center so that I can pass all the data to see what is the state of my system. Yeah. Now these devices run different protocols. Modbus is one of them. I'll talk about it in a minute. So then you got PLC. What is PLC? Programmable logic controller. What it does? It's a controller. You can put a logic, you can put a code, and it will execute on the basis of that. Yeah. For example, I can put it saying I'm sensing a data. If my data is kind of less than 50 hertz, it will pass, otherwise it will not pass. So you configure it, you can write a code in order to control the environment. Something is called SCADA system. What is SCADA? Supervisory control and data acquisition system. So this is part of your control center. So as I said, all the substations send their data by RTU. RTU will send it to the control center. Control center having a SCADA system. This will fetch all the data, run its algorithm, power algorithm. I'm not going to detail in this. And then based on that, it will decide what needs to be done. For example, in one of the areas, there's a huge demand of power. You need to take certain actions to fulfill that demand. You start providing that power from some other areas and so on. You're connecting and disconnecting lines and so on. So you make those decisions once you're able to pass that data and get to see the big picture. Now power companies also do something called forecasting, load forecasting. So they are well prepared in advance. And generally they have kind of a 1 day ahead. Then they get a sense what's going to be demand for tomorrow and how they're going to fulfill that demand by whatever they have as today. For big events, for example, there's a Diwali fest. People will lighting up and so on, candles and so. There will be higher demand. So they're well prepared how to provide, how to meet that expectations ahead. Yeah. So for expected events, they might have forecasting. They can easily predict. Sometimes it's unpredictable. For example, COVID. There's a sudden drop of power at businesses, and there's a high spike at home. People were working from home. Those were unexpected for first few days, but then they get a sense. So you learn from historical data. So they learn from historical data to decide on what will be the demand on this time or this week, and they accordingly project how they will meet that demand. What operation, what decisions they need to make, and so on. Again, there are different systems: power system, water management, transportation, natural gas, nuclear, oil. They all are cyber physical systems. Right. I'll just quickly jump one more slide. Now, connected components. There's a saying called connected autonomous vehicle. Now we know autonomous vehicle is called, where we say driverless vehicle. Now driverless vehicle cannot run by its own on the road. It needs to know the environment. When you drive, generally you look for, when you overtake, you look for whether someone is coming on the right or not, whether there's a pedestrian or not, whether how's the route look like, whether the vehicle behind me or beside me is going to be autonomous vehicle. It's a driver-based vehicle. So you need that data as well as an autonomous vehicle. I'll be talking about autonomous vehicle in the lecture in more detail, but then we are talking about connected component. So that means your vehicle, obviously, currently your vehicle sense a lot of data within it, and this data has been sent to the manufacturer for improvement and so on. But then in reality, when you see the autonomous vehicle on the ground, we need to sense a lot of data, sending it to process, and that data will be broadcasted to all other vehicles so that they get a sense what does the environment look like around them. And then only they can survive, otherwise they will hit somebody. In a similar way, we have devices, some different type of devices. Maybe you are able, now you got mobile phone, different app where you can control your vehicle. Yeah? So all these things are interconnected, and once they've been attacked, one part of the system is attacked, there's always possibility it can influence the other part of the system. So I'm not scaring you, but the situation is, in order to come to a point where we say we have a smart city, it's not an easy thing. We have to learn things, we have to be skilled in order to control things, in order to maintain those things. It's not just about building things, it's about controlling things when they go wrong. If everything is working fine, you're fine, we don't care. When things go wrong, if you don't have control over it, it will destroy everything. Yeah? So I'll stop here, and we will continue tomorrow from here as well. Any questions, what we have gone through today? I think I just try to be more holistic, not going into more detail, but then give a sense out of it. We have one tutorial, I guess, as well, yeah? Tutorial, okay. So what time they have?